Hello all, welcome to AK Apt Logics. Today we are going to discuss about the how to represent negative numbers in Verilog. Yeah, in the previous class we have discussed about the how to represent unsigned number. Okay, and in the before that class we have discussed about the size number. Now in this class we are going to discuss about how to represent negative numbers. Okay, to represent negative numbers we have to use the symbol minus, right? So the negative numbers are specified by placing a minus sign before the size of a number. Okay, to represent any number we have the syntax as uh, size, tick mark, base format followed by the number. Okay, this is the syntax which we have discussed in the size numbers representation in the previous class. So to represent negative numbers we have to represent minus sign in front of the size. Okay, in front of size we have to mention the minus sign. It is illegal to have a minus sign between base format and a number. This is the point we have to remember. So let us see an example. So if you want to see this particular example, so let me keep this as an example. Yeah. If you're gonna see this particular thing, so here minus 6 tick d3. What's this meaning? What is this mean? So minus is kept before the size, right? Here 6 is the size, tick is the thing which we have in the syntax, so we have used it, and d is the decimal. It means the number after the d is in the form of decimal. It means 3 which is a decimal number, 3 which is a decimal number which occupies 6 bits, and it is a negative number. How we gonna able to know that it is an a negative number is before the size 6 we have the minus. So if you want to see this comment, 6-bit negative number stored as 2's complement of 3. Okay, this particular number will be stored in the 2's complement of 3. So what is the size of the, what is the number? So let me represent what is the number. 3 is the number. Okay, how many bits it is going to occupy? 6 number of bits, right? Let us represent 3 in 6 binary bits. Okay, this is the 3. So how it gonna be stored? The 2's complement form. Let us write the 2's complement form for this particular thing. So to write that we have to write 1's complement, right? By just inverting zeros to ones, so ones to zeros. This is the 1's complement, plus we have to add 1 to it. So the number will be represented as 4 ones 0 1. This is the thing, this is the thing minus 3 means. Okay, this is means 3, this will be minus 3, which is the 2's complement representation of 3. Okay, yeah, let us see the second example. Minus 6 tick d sd. What is this sd mean? We in the previous class we have discussed only decimal, hexadecimal and binary and octal, right? What is this particular sd means? This is also a base format used to represent signed decimal. Okay, SD means signed decimal. Okay, in this case the number is 9, which is a 6-bit number. This is also actually 6-bit number, and is it's a negative number. So let us write also represent this particular thing in the number. So 9 can be represented, you know how many bits we have to represent this particular thing? 9 in the 6 number of bits. So let us represent 9. 9 will occupy 4 number of bits, and we gonna add 2 more bits to the MSB as zeros. So let us represent this particular binary format of 9 in 2's complement. Let us represent. To represent we have to represent it as 1's complement plus 1, right? So if you're gonna represent, then the value will be this thing 110 111. Okay, which is a 6-bit number, which is a 6-bit 2's complement number of 9. Is it okay? Yeah, similarly this is an invalid thing. So the third example we have the invalid thing, 8 tick d minus 4. Here we have used the minus sign in between the base format and the number. So it is illegal, as I have mentioned in the second point. It is illegal to do. Let us take an example. We can solve all these particular things. Okay, yeah, let me take an example. Yeah, this is an example. in which we have declared so let me erase this. I have done a paperwork, so I will explain you. Okay, yeah, this is an example. I have declared a module whose name is nick number, so I have actually showing the nick numbers, right? So I have declared a variables a and b which are type of range, and I have declared them as vectors. What is mean by vector? Vector is nothing but a how can I able to say, see, this is the thing, a. So we have if we let me take a number 1011110, which is 6-bit number. So I gonna represent this particular number in a. Okay, using the reg. So reg is a single bit reg is a data type which whose default value is 1 bit. Okay, so if you want to store this particular number a using reg, so I have to declare what is the size of this particular bits, 6, right? I have to declare uh, as reg 5 down to 0 a. 5 down to 0 a means 0 1 2 3 and so on up to 5. We have six number of bits, right? So what does it mean if you're gonna if I gonna assign like this 6 tick b 101110? What happens is, so a contains individually numbers. See, so like this the a will be stored. How much? See, the a5 value will be this particular one. Okay, msb, and the a of 0 will be the lsb. Okay, a of 4 will be this particular 0. Okay, like this this whole thing represent only single number. Okay, uh, all the individual a of 5, a of 4, a of 0, all these particular thing represent a single number. Individually they are bits. Okay, but combination of all these represent only a single number. Okay, that's the representation of vector. Okay, how we gonna represent a vector is, first we have to write the data type, and after we have to mention the size of the vector. So in this case, in this particular example the size is 6, so 5 tick 5 down to 0. I mentioned 5 down to 0, and we should represent the variable after the size. I have represented a one variable, and I also represented another variable b. Okay, here in this case b is not in reg of single bit, it is also a 6 bits value. Okay, remember this point. Reg is a default reg is a data type whose default size is single bit. To extend the number of bits, okay, we have the vector. Okay, so I have extended this particular a to 6 bits, and I also extended b to 6 bits. Reg is a single bit data type. This particular vector representation can only possible with two types of data types, who they are wide and rich. Okay, remember this point. And when it comes to integer, there is no concept of vector representation. Why? Because integer is default size of 32-bit. Okay, if there is a vector if you assume that there is an vector concept to integers, then integer 5 down to 0 a comma b, there is no any concept like that, because integer itself with the default value of 32-bit. Okay, it means if I gonna represent this like this, integer a is a size of 32 bits. Okay, whereas in reg a is 1 bit size default. Okay, if we want to extend this, so we represent 5 down to 0. Now a becomes 6 bits. A is a single value which carries 6 bits. Okay, all these 6 bits represents the value of one number only. Okay, yeah. But if you have want to take the concept of vector to, there is no use of concept of vector to the integer actually. Why? Because integer is actually a 32-bit number. So we shouldn't use this particular vector concept to integers. We should only use this particular concept to the reg and wire data types. All these things will be discussed by me in the future classes, but for now, to understand why I have taken like that, so I'm discussing right now. So just forget these things to make you clear this example I have discussed right now. In the future classes I will explain more deeply. Okay, yeah. I have declared the reg, which is a data type, and I have used the vector notation, and I have used two variables a and b. So I have declared the initial block which executes only one time, and I have assigned the values to a and b in the initial block, which are these values. Okay, which are actually these values. Okay, so I have written dollar display statement to display this particular a and b values for the first time as as decimal values. So see, if you're gonna see this, I have used format specifier as %0d. Okay, to make this a and b to represent in decimal value. In the second display statement I have used %0b to make to show a and b in binary bits. So let us write the what is the assumed output. What is the assumed output? So what we are going to expect? We are going to expect a value as -3 and b value as -9, right? So we have I have seen said you right here, right? Yeah. For the case of binary, we are going to expect a value as this one, right? I have shown I have explained you before, right, how to represent this particular number 3. So let me copy this. Yeah, we are expecting this particular 2's complement representation of -3. For the b, we are going to expect the 2's complement representation of 9, which is actually in the 6 bits. Okay, we are going to expect these particular things after execution. So let us see whether we are going to get those things or any other things. Yeah, let me run this code. Yeah, see, yeah, if you're gonna see, I got 61. how how did you got? And got b as 55. How 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 does it happen? Actually I have used %0d, right? For the a and b, the number is -3, and for the a the number is -3, for the b the number is -9. So when we are going to use %0d, we should get a equal to -3 and b is equal to -3. But why did I get 61 and 55? How does it happen? Actually happen. And for the second case, let us see. We got the expected output. This case is correct. We got right. But the first case, we didn't get what we expected. We get 61 and 55. How? Why does it happen? Let me explain it. Yeah. Why we got 61 and 55? So if you're gonna see how many number of bits that we have taken to represent these particular numbers, 6 bits, right? The maximum uh, number of bits that we have a number of values will be 2 power 6 will be how much? 64, right? The maximum number. Okay, it means the total number of numbers that we can to represent using 6 bit. We can represent 64 values using the 6 bit. Okay, and by default reg is a unsigned. By default reg is a unsigned data type, Remember this point. By default, reg is an unsigned data type. So using 6 bits, we can able to represent 64 values. Those are from 0 to 0 to 63. Okay, 0 to 63. Okay, so how many numbers that we can able to represent? 64 values. So simply why we get 61 means whenever we are going to use the represent the negative numbers, which is a minus 3, we have to subtract the 3 from the maximum number of values. Maximum, not the maximum value, total number of values number. It means 64. 64 minus 3 will be 61. So I'm going to say you a simple shortcut. Okay, remember. Yeah, so we get 61 as output. For the case of 9 also we have used the 6 bit, right? 2 power 6 will be 64. It means using 6 bits we can able to represent 64 values. Okay, whether the all those are negative and positive, or only positive or only negative will be decided by this particular data type reg. That reg data type is unsigned by default, so that we are going to represent, we can able to represent 64 value as positive only. Okay, why? Because the reg is unsigned, right? So we can able to represent from 64 0 to 63 only. So we can't able to represent minus 3 and minus 9. Even though we have used the percentile 0d, we have used the reg, which is an unsigned data type. So using 6 bits, we can able to represent some value, total 64 number of values. In that 64 number of values, we can only represent from 0 to 63, which is an unsigned representation. Why? Because reg is a by default unsigned data type. Okay, yeah. So for the case of 9 also, total number of values that we can represent minus 9. What is the answer? 55. So we got 61 and 55 like this. Okay, so what we have to do to get a resultant as minus 3 and minus 9? To get resultant as minus 3 and minus 9, we said we should use the uh, modifier. Okay, we have to use the modifier that is signed over here. Let us see whether we are going to get it or not. So let me check. So the video is getting lengthy, but it will be very useful if you're gonna practice. Yeah. Wow, we got an error. Yeah. What is the error? Where is the error? Yeah, 231, which we have used the sign, right? Why we are going to get this error? Syntax error, error invalid module item. So why we are going to get this error means I have used the modifier, which is a data type modifier, before the data type. Before reg, I have used the signed. So you shouldn't use before reg. You should use after reg. So this is the point you should remember. Okay. Yeah. Let me run this code again. Yeah, there are no any errors. Let me run this code. Yeah, you can able to see that a equal to minus 3 and b is equal to minus 9, and a and b in binary format as usual. They are correct, right? So let me remove this sign and let us check by placing signed decimal as format specifier whether we are going to have it or not. In the case of base format, we have SD, which is a signed decimal. So similarly, let us check whether it is going to work or not by representing percentile SD. Yeah, sorry. Let me run this. See what happens. Sorry, I haven't saved the code. Actually, it shouldn't get because we don't have any percentile SD. I haven't saved the code so that the previous result is getting printed. Yeah. So we can able to see here we got the resultant as A equal to D, B equal to 70. Why we get this I don't know. Really I don't know. Yeah. So using percentile SD is not a thing. Why? Because there is no any percentile SD. Let us check percentile 0 SD if possible. We have to check like this. Then only we can able to learn, and we then only we can able to understand everything. Yeah. So there is no percentile SD as format specifier. But in case of base format represent while representing the number, there is a base format as percentile SD. Remember this point too. Yeah. So as usual, I am gonna represent this side. So let me write all the points down here. The video is getting like very lengthy. So let me conclude with these short notes from this code. Okay. Yeah. I'm gonna stop this video and again resume. Yeah. Before that, let us replace this particular data type with integer and see what we are getting. So, and remember we haven't used any modifier. So let us check what the output will be. We get the output as a equal to -3 and b equal to -10. But the thing is, a and b values in binary we get in 32-bit format. Why we get 32-bit format is by default integer is a 32-bit number, and why we get a equal to -3 and b equal to -3 even though without we are going to use the uh, modify without modifier means integer is a by default signed data type. Yeah, so integer is a by default signed data type and which is the default size of 32 bits, so that we the reason we get the a and b value as 32-bit format in when we are going to print in binary. So but the MSBs are getting filled with 1. Why the MSBs are getting filled with 1 is the reason is when we are going to print the negative numbers in the binary format, the MSBs will get filled with 1. Remember this point. Okay. Even though uh, if you wanna check over this in this example, we have represented 3 in 6-bit format, right? Yeah. When we going to get this particular number in 2's complement, we get 111101. So even if you add one another 0 to the MSB, then 1 will be added in the 2's complement form. Okay. Yeah. So that's the thing. It's better to use the ridge rather than considering the integer. Why? Because integer default size is 32 bits. So same the value in case of range, it took 6 bits for the value of a and 6 bits for the value of b. For in the case of b, for in the case of integer, it took 32 bits for the value of a and 32 bits for the value of b. So it's better to use the range data type instead of using the integer. Yeah. So this is the thing, and this is the points to be observed while you are guys are going to do. Yeah, there is SDS base format while representing the negative number, but there is no format specifier. The SD is only we have in the base format. While we printing the number, we shouldn't use percentile SD as format specifier. The a equal to 61 and b equal to 55 when we use reg data type only because reg is unsigned by default. So the negative numbers will be subtracted from the total number of values that and that value will get printed. Here in this case, total number of values is 64. Why? Because we have used the 6-bit number. So 64 minus that particular negative number, whether it may be a 3 or 9 or any other number. When we use the signed modifier after rich, then we can see the a equal to -3 and b equal to -9 displayed. We shouldn't use the modifier before the data type. If so, we get the module item error. Okay, we shouldn't use modifier before the data type. Okay, we should use modifier only after the data type. Okay, without using the modifier with integer, we get the values as a equal to -3 and b equal to -9 because integer is signed by default. Okay, this is the points you should observe. Thank you guys. With this, I'm concluding this video.